All right. So we're looking at the 3538 practice worksheet, and I'm going to do a few of those selected problems that we discussed in class. It's problems number 1, 7, 14, and 26 from that worksheet. That way we have a hopefully we have a better idea as to what is happening with each one of those. So let's take a look first. Let's take a look at problem number 1. It says P is the set of integers. Now I want to take note of that. Let's take note. Where are you? Okay. P is a set of integers, so I'm going to underline the word integers, just so I can remember what are integers. Those are the numbers on a number line. They're the whole numbers, or the tick marks, I'd say, on a number line. So P is the set of integers that are greater than 35. So in roster form, remember roster form is where we just list them out. Well, there's an infinite amount of integers bigger than 35, so we need to be real careful with the way we say what we say here. But P is equal to, now I need to be able to show integers bigger than 35. So we start with 35. Well, 35 is not bigger than 35, so we have to say 36. And then we get to 37. And we say 38. Now I could keep going, but that would take us forever in the rest of my life, and I don't have time on the video because YouTube stops it at 14 minutes. So let's just put a little dot, dot, dot here. And that tells me 36, 37, 38, yada, yada, yada. And it goes on forever. That dot, dot, dot tells me this is going to keep on going forever. And then in set builder notation, I would say P is the set. P equals the set of x values such that x is an integer where x is greater than 38. So here in set builder notation, now P is the set, so P equals this, but then we have to define the variable for the elements within the set. So the set of x values such that x is an integer, comma, where x is greater than 38. Oh no, 35, sorry. Excuse me. Let's correct that. Greater than 35. Sorry about that. So again, P is just the name of the set. X is the name of the variable that represents the elements within that set. Alright, so the next one we're going to do is 7. Oh, look here. There's those dots. So starting at negative infinity, and then we get to negative 5, negative 3, negative 1, 1, 3, 5. And it's this is my universal set. R is a subset of that universal set. So it's 1, 3, 5, dot, dot, dot. So R prime. Now, R prime this means let's see, how do I want to write that? R prime is the complement. It's the complement of R. And now remember, the complement is all the other numbers except for what is in R. So the other numbers that are in the universal set but are not in R. So R prime in this instance, R prime would be all the numbers from negative infinity. So starting off there, and we say negative 5, negative 3, negative 1. And then we'll close it off. Because 1 is in R. So I don't want to keep going because 1 is already in R. But negative 5, negative 3, negative 1, that is not. So that's why that becomes my complement there. Alright, so 14. All real numbers that are greater than or equal to negative 2 and less than 4. The directions, excuse me, the directions for 14 say, write the set in interval notation that represents the phrase and then graph the solution. Well, I think it's easier to graph it first and then ask what the interval is. So here I'm going to say 0. Over here I have negative 2, and way over here I have 4. So they're greater than or equal to negative 2. So that's going to be closed, right? And it's strictly less than 4, so it's going to be open. And I'm going to shade in between, because this is less than 4 and these are greater than negative 2. And using interval notation, negative 2 is included, so I have my brackets here at negative 2. And then I go all the way to 4, and then I use my parentheses. So there, x can take on values between negative 2 and 4, including negative 2, but not including 4. So here, this is how that's graphed, the graphical representation of that. Okay, so for number 26, solve the inequality and then give the solutions in interval notation. All right, so here, this is less than. My absolute value is less than 12. Remember, that's less than. Excuse me. So, just as a reminder, I like to do this sometimes. Here it tells me I have an and compound inequality. For the and compound inequality, I take this, since it is positive, mind you it's positive, so I start with negative 12 is less than or equal to, and then everything on the inside, 2x plus 8, which is less than or equal to the positive version of 12. And now I want to solve until I have x all by itself in the middle. So here I'm going to take 8 away from both sides, or all three sides actually. So take 8 away. So negative 12 minus 8 is negative 20, which is less than or equal to 2x, which is less than or equal to 12 minus 8, which is 4. And now I can divide everybody by 2. Divide everybody by 2. Dividing everybody by 2. Negative 20 divided by 2. It's negative 10. Negative 10. Let me make sure that's good. Negative 10. Oh, that one looks terrible. My eraser there. All right, so negative 10 is less than or equal to x, which is less than or equal to 2. So I want to give that in interval notation. Well, this symbol here tells me it's included. So given my answer in interval notation, x can take on values between negative 10 and 2, and I'm including both of them. So here's my answer using interval notation. Again, it's brackets, negative 10 to 2, brackets. Hopefully you found this helpful, and we'll spend some time answering questions in class. And tomorrow is our review day, so it should be something that we need to make sure we know before. Make sure we know these before the test, which is coming up on block day.